Alright guys, so hello everyone and welcome to my YouTube channel Dissonant Academy. And guys, we are going to talk about previous year questions on IR spectroscopy today, okay? So I hope that you have watched all the previous videos on the concepts and the structure determination for the IR spectroscopy, and today we are going to talk about the previous year CSIR questions basically, okay? Alright. Okay, so before moving on to the class, I would just want to introduce myself as an unacademy educator as well. So if you have already visited my profile, it is great. But if you have not yet visited, I would suggest you to once go through the profile, because you are going to get a lot of free content, or let's say a lot of options, right? See guys, let me just briefly explain what are special classes basically. So special classes are free live classes, and you are able to attend those classes, you are able to interact with me, right? Okay, so these are very interactive live classes. Okay, also the recordings of all the live sessions are available in my bio as well. Okay, so if you visit my profile, you are going to see this picture over here, and if you just click on this, then you are going to the video is going to start and you will be able to watch the free 1 hour session. Similarly, there is a plus platform, and the plus platform is basically a paid platform, guys, right? So if you like the content in the special classes, then you will be able to decide that if you want to subscribe or not, because special classes are a glimpse of how the plus class is going to be basically, okay? So in the plus classes, it can be, most of the times we are having a 90-minute session, which is a 1.5 hour session, and also we are focusing on completing the syllabus, right, for the CSIR NET exam. And right now I'm starting my course for June 2020 preparation in the month of January. You can get all the details on the Unacademy website about the course, okay, about the upcoming courses. And guys, if you wish to let's say subscribe to the plus course, then don't forget to use my code, which is Jagriti S. Why? Because this code is going to give you a 10% discount on any subscription package. It can be a 1 month subscription, 3 month, 6 month, 12 month, as well as 24 month subscription. So it depends on you. If you like the content completely, then guys, it would be great if you join us, because we are going to start a preparation for June 2020 very soon. And also I will be taking some special classes for the GATE 2020 preparation as well, so you can also come up in the free video sessions, okay? Alright, so let's begin with our first question for today, the CSIR UGC NET 2011 December. So I know that it's a very old question, but nonetheless it's a very important question, and we have to see that what are the singular, or let's say individual questions which are asked from the IR spectroscopy itself, okay? So the first question is, in the IR spectrum, carbonyl absorption band for the following compound appears at. So basically for the lactone we have that we are having over here. So for this lactone, we just have to determine what is going to be the correct frequency from A, B, C and D. So this is the whole question, okay? Alright. So guys, if you have already watched my previous lectures on the IR spectroscopy, then you would know that as the ring size decreases, as the ring size goes from a 6-membered ring to a 5-membered ring, definitely the IR frequency value is going to increase. Also, we are having a carbonyl system, as well as the in the cycle there is also a heteroatom oxygen. So basically for lactones, for acyclic lactose, the value is something greater than 1735 centimeter inverse. That is for acyclic system. But for cyclic system, it is usually around 750. Okay, and that too, when the ring size decreases, then what happens? The value goes on increasing because of the ring strain that it is facing basically, okay? So now I'm going to give you some basically extra knowledge about the type of lactone and about the frequencies which are possible. So if we are considering a cyclic ester, which is a lactone, then what are the various systems that can be asked in the CSIR exam basically, that I'm going to show you over here, okay? So yes, just like I have told you, acyclic esters are usually having this frequency range 1735 to 1750 centimeter inverse. Okay. Also, cyclic esters are having a greater value than 1750 because of the ring strain. Okay. All right. Okay, so what are the systems that I'm having over here? First of all, I have taken a system, a 6-membered ring lactone basically, in which I have taken a double bond over here like this. Okay, so this double bond is basically going to determine if the value is going to increase for the carbonyl group or if it is going to decrease. Okay, so let's look at the first example over here. So in our first example, what do we see, guys? There is a carbon-carbon double bond over here, okay? And it can undergo resonance with the carbonyl group, isn't it? Also, the oxygen can undergo resonance with the carbonyl group. So basically, the presence of a carbon-carbon double bond over here close to the carbonyl like this, in the alpha-beta position, basically, this is going to take part into resonance, and because of that, the frequency for carbonyl decreases. Right, this is the effect of resonance on the frequency, right, or basically wave number we can say. Okay, so definitely the specific value for cyclic ester, which has to be around, or let's say greater than 750, it is reducing. Okay, all right, so this is 1720 centimeter inverse over here. And when we are having only cyclic ester, which is basically our cyclohexanone system basically, right, because here we are having 6-membered, one of them is a heteroatom definitely, but here we are having a 6-membered cyclic lactone. So for this, the value increases to 1735 centimeter inverse. Now we are having one such system in which we can see that the double bond is placed close to oxygen. So basically this system is a kind of a vinyl ether system. Yes, only considering this system, right? So this is kind of a vinyl ether system. And what happens is, what is going to happen? See, usually in the ester, what happens? The lone pair of oxygen are, giving resonance with the carbonyl group. But over here, what do we see? We see that the lone pair of oxygen can also undergo resonance to this carbon-carbon double bond over here, and because of that, what happens is the carbonyl group is not getting as much resonance as it was getting before, and that is why the frequency value increases. Because of this reason, it increases. So you might get a question in which the question is asking you individually that what are the frequencies for this particular compound, or you might get a question in which for all of these 3 type of esters, the value is compared. Basically, let's say the question is asking you what is the decreasing or increasing value of the frequency or wave number for these 3 esters. So this is how you are going to understand and answer. Okay, so yes, also talking about 5-membered ring system. Here it was 6-membered ring system. We are also going to talk about 5-membered ring system. So basically over here, as we can see, if we are having a double bond which is again giving resonance with carbonyl group, the value is decreased 1750 centimeter inverse. If we are having our simple simple 5-membered lactone, then it is going to be 1770 centimeter inverse. And if it is the pi bond is closer to oxygen like this, making it a vinyl ether system, then the value is going to increase to real high, right? So this is our maximum value, 1800 centimeter inverse. This is for the double bond having which is closer to the oxygen. So right guys, so we are asked about this system in the question. If we go back to our question, then we see the only 5-membered lactone system is asked. So definitely we are going to say that 1770 is the value, isn't it? So this was a very easy question, but what you have to take care of is that you have to remember at least the base values. So for a 6-membered lactone like this, the value is going to be around 1735 centimeter inverse, and for a 5-membered lactone system, it is going to be around 1770 centimeter inverse. Okay, so I think you will be able to remember these 2 values. If not all, then these 2 values, and the rest you can determine by the logic, by the conjugation logic. Okay, how much the carbonyl is getting the conjugation from the pi bond. Okay, so now we are going to move on to our next question, and let's see what do we have over here. So in the CSIR UGC NET exam, June 2015, this question was asked: intense band generally observed for a carbonyl group in the IR spectrum is due to. So this is a very tricky, it's a very easy question, but at the same time it's a very tricky question. Why, guys? Because the question is asking intense band generally observed for a carbonyl group. Okay, so I have already discussed about this, that when the wave number or the frequency is asked, at that time you are going to think about force constant. Okay, why? Because the formula goes like this: 1 by 2 pi c under root of k by mu, and this k is our force constant and mu is our reduced mass, and this is our wave number basically. So basically, guys, here the question is not asking about greater wave number or shorter wave number. Basically the question is asking about intensity. Okay, so the question is asking about intensity. So I have given you enough hints, and I just want you to stop the video and try the answer by yourself. Okay, all right, so now I'm going to tell you the answer. So guys, again, if it is asking about intensity, who does the intensity depend upon? It depends upon dipole moment, and the same question was asked, guys, in the December 2019 exam. There was only a little difference, a very minute difference. Molar absorptivity coefficient was asked, let's say, or let's say molar absorption coefficient, which is our epsilon. So epsilon is usually asked for forbidden or allowed transitions. Also, the molar absorptivity coefficient is directly proportional to intensity. Yes, guys, because the greater the intensity, the greater the molar absorption coefficient, right? So these three things can be asked. Either the question is directly asking you dipole moment, or the question is asking you intensity, which is there in this case, in the case of this question, or it can ask you molar absorptivity coefficient, which is also directly proportional to intensity. Okay, so now I think it will be very easy for you to answer this question. Yes, so in the IR spectrum is due to the force constant of carbonyl bond is large. So if the force constant of the carbonyl bond is large, then the wave number or the frequency must be large, but the intensity is having no effect from the force constant. Yes, so we are not going to tick A and B, both of them we are going to eliminate. Right now, option C and D we are going to see. There is no change in dipole moment for carbonyl bond stretching. That is not going to happen, because even if it is stretching symmetrically or antisymmetrically, it is always going to have a dipole moment. Also, the option number D is saying the dipole moment change due to carbonyl bond stretching is large, and this is the correct answer, guys, because we have already studied that intensity depends upon dipole moment. Okay, I hope that this concept is clear to all of you. All right, so I think I've written the answer for it as well. Yeah, just so I've just showed you the formula for frequency, and this is the reduced mass, this is our wave number in centimeter inverse. So the intensity of IR spectrum band is dependent mainly on magnitude of dipole. More polar the bond, greater the intensity of the IR band. So for carbonyl intense band is observed due to large dipole moment because of the bond stretching. Okay, I hope that this concept is clear to you guys. Okay, so now we are going to focus on one more question which was asked in December 2016 CSIR UGC NET exam. Okay, so the question is asking, okay, so again I would suggest you to stop the video right here and try it by yourself. Okay, so the compound which shows IR frequencies both at 3314 and 2126 centimeter inverse is. So guys, this is a very easy question and you have to try it by yourself. So the question is asking us for a compound which is having frequency at 3314 centimeter inverse as well as 2126 centimeter inverse. So as I have told you, you don't have to remember the exact value for any functional group, but you must have a rough idea of the frequencies of all the functional groups basically. So what are we given over here in the option? Let's check that. So we are given a thiol in the first option, we are given a nitrile in the second option, we are given a terminal alkyne. So this is our terminal alkyne in the third option, and we are having a substituted alkyne basically. So this is not our terminal alkyne, and over here it is not going to have a carbon hydrogen interaction basically. So there is no carbon hydrogen interaction. Also let me just tell you one more thing. If we are having a symmetrical alkyne basically, as I can see, yeah, this is symmetrical, isn't it? Symmetrical, guys. So when we are having a symmetrical alkyne, then the antisymmetric or the symmetric stretch is going to cause a very less dipole moment change, and the peaks are going to be really bad. The peaks are going to be not visible. If you have already seen my videos, you are going to correlate it very quickly. Just in a second you will be able to say, oh ma'am, this is not going to give any peak. Why? Because the dipole moment is very less, the intensity of the peak is very less, very weak peak. Okay, so these peaks cannot be absorbed for alkyne system, which is a substituted symmetrically substituted alkyne. Right, now we are having these three options. Okay, so let me just ask you one more thing, that the OH group, usually the alcohol, is showing us the OH bond stretching frequency at around it's greater than, or let's say around 35 centimeter inverse, and it's a broad peak. Okay, it's a broad peak if you have seen the spectrum. Okay, so now we are increasing the mass to SH basically, and the sulfur hydrogen stretching frequency is going to come to a lower value. So it is going to come to a much lower value as compared to 3500 centimeter inverse. Not even this, at a much lower value. Okay, so again for nitrile, for the carbon nitrogen stretching frequency, we can expect a peak at around this system. But what about this peak? Okay, so basically I'm just going to tell you. Yeah, so I'm just going to explain it to you once again. So carbon hydrogen stretching frequency, which we always expected to lie around 2900 centimeter inverse to something 32 to 3300 centimeter inverse. Why this? Because the sp3 carbon hydrogen stretching frequency lies at around, no, this is less than 3000, and the sp2 is at around 3200, greater than 3000, and the sp carbon hydrogen stretching is going to be around 3300 centimeter inverse, much greater. Okay, we know this already, so we can just spot out that this is our sp carbon hydrogen bond stretching frequency. Okay, internal alkynes do not show this band because we have already discussed that. Carbon-carbon triple bond stretching frequency is also at around 2200 centimeter inverse. So I just roughly remember the value, that 2200 centimeter is our carbon triple bond carbon stretching frequency. Okay, so yeah, it is going to lie, the value that is given in the question is definitely lying in this region. So it must be our carbonyl triple bond stretching frequency. Similarly, the carbon nitrogen stretching frequency is also there in the same value. Alright, but the sulfur hydrogen stretching is shown at 3584 to 2598, which is approximately around 2500 centimeter inverse. Okay, so just like I've told you that oxygen hydrogen stretching frequency is at around 3500, but for sulfur it decreases to a lower value because the reduced mass increases, which is inversely proportional to the wave number. That is why the value decreases to this low value. Now we can confirm in this question, definitely for thiol we are not having this value. Why guys? Because the functional group shows at around 2500 centimeter inverse. Secondly, all the hydrogens are sp3 hydrogens. they cannot have such a high value because sp3 hydrogens must show at around 2900 centimeter inverse. So option A is wrong. Similarly, for option B, the CN stretching frequency is at around 2200 centimeter inverse, which can be this, but no, we are not having any explanation for this peak. Okay, so B is again wrong. D is wrong because symmetric alkene, no value it is going to give, basically very weak peak, and there is also no carbon hydrogen stretching. So we are having the confirmation for this group, the terminal alkyne system basically. So for the terminal alkyne, we are always going to have two bands like this. One is our carbon hydrogen stretching frequency and the second is carbon carbon triple bond stretching. Okay, so our answer is option number C. I hope that you are able to understand the question in all of the mess. Alright. Yes, everyone. So now I can just move forward to another question. Or basically guys, in the upcoming video or in my next video, I will be solving more and more questions on this. Okay, so I can just do that. Yeah, in our next class we are going to talk about more questions, right? And definitely guys, if you like this video, then please give it a big thumbs up and also share it to your friends and also subscribe. And guys, if you have already viewed my profile on unacademy, it is really great. Otherwise you can follow me on unacademy for regular updates on all the free as well as plus classes, because from the month of January we are going to start our process, our studies for June 2020 examination completely. And don't worry if you have missed some classes, because all of the classes are recorded. All of the classes are recorded just like this one, and it will be available to you whenever you want it. Okay guys, thank you so much for watching this video and I'll see you in the next session. Thank you.